All right. If you are starting, we're going to start this week talking about correlation and regression analysis. This is part two of this section of the course. So, if you remember back last week, we went over our learning objectives. The first part of this lecture went over correlations and linear and multiple regression. This week we're going to talk about logistic regression. And before we get into that, I am going to review some concepts of sensitivity, specificity, ROC curves, and some concepts on event probability analysis. I think these are important, and they'll help you better understand logistic regression and some of the content that's going to come later in this course and in your program. So last week we talked about correlation coefficients, simple and multiple linear regression, and you can see what we're going to talk about for this lecture. All right, just like all the other videos, lectures, I have some videos that I found on YouTube that will help reinforce the concepts we talked about, or maybe do a better job of explaining some statistical concepts than I could certainly do. So please take some time to watch these. All right. What is prevalence? Prevalence is the proportion of the population that has a disease. And so that is how you calculate a prevalence is you take the total number of subjects in the population, and you take the number of subjects who has a disease or some condition, and you divide them by the total number of subjects in the population. So a good way to remember prevalence, P, population. And so that is in contrast to incidences, which is the number of existing cases of a disease or an outcome. Maybe it's the incidence of postpartum hemorrhage in a group of subjects that were followed for a period of time. And so these are the number of subjects who develop a disease or a condition or an outcome divided by the total number of people followed for that period of time, or maybe within that cohort. And so many times in research studies, because we're using samples, we're reporting incidences as opposed to the prevalence rates. So here's a good illustration of the difference of how prevalence and incidence play together. And so you have the population who is at risk, and then you have a number. Incidence is the number of new cases, and that goes into that prevalence bucket. Prevalence increases as the incident cases are added, and prevalence decreases as the cases die or recover over time. Here's some characteristics of measures of disease frequency that I think are helpful for understanding. So prevalence represents existing cases at that point in time. Incidence can represent cases over a period of time. They also talk about prevalence can reflect disease burden. Whereas this may be an assessment of disease etiology, identification of risk factors. And you can see some synonyms here. They're both usually on probability 0 to 100 ranges, and so on. So what is a risk versus an odd? So risk is the probability of a health event actually occurring. Sometimes this may be adverse events. The relative risk is the is the likelihood of its occurrence after exposure to a risk variable, or as compared to the likelihood of its occurrence in the control of the reference group. And odds is the ratio of the probability that an event will occur, such as postoperative nausea and vomiting, in relation to the event not occurring. And so with that, we'll count an odds ratio, which is where we compare those two. So here's a little better rendition. Many times you're going to see relative risks reported in cohort studies. So with a relative risk calculation, what they're doing is they're taking the probability of getting the disease if they're exposed, comparing that to the probability of getting the disease if they were not exposed. Okay? Or you can look at it as the probability of an outcome if they're on a drug compared to the probability of that outcome if they're in a placebo group. Sometimes you'll see relative risk reported in clinical trials. And then the odds ratio is the odds that the diseased were exposed over the odds the controls were exposed, or that the event occurred. Okay. Here's another way. So usually these come from 2x2 tables. So you have a risk ratio, also referred to as the relative risk of an event occurring. And so you can see the calculation here. Basically, you have intervention, or say if this is like a randomized trial, this is the rate in the intervention group, this is the rate in the control group. So you have yes, it occurred, no, it didn't occur. The control group, yes, it occurred, no, it did not occur. Okay, and you can calculate that way. An odds ratio is essentially, it looks at the same way, but it calculates it has a slightly different way of calculating it. Both of them have the same scale of measurement in terms of how you might interpret those what you might call the effect size. So if it's greater than 1, say for example, if the odds ratio or the risk ratio is 1.5, that means that rate, if it's a risk, they're 50% higher risk than average, or the odds are 50% higher than the other group, and it's opposite if it's below 1. So relative risk, as we've already talked about, is used to compare that risk of developing the disease, sometimes in people not receiving a new medical treatment, or maybe receiving a placebo, when compared to those who are receiving that treatment. And it's also used in clinical trials. And a simple comparison between, say, an experimental control group that reports relative risks is if a relative risk of 1 means there's no difference in risk between the two groups. If the risk is less than 1, that means the event is less likely to occur in the experimental group compared to the control group. And if it's greater than 1, it means that risk of that event occurring is more likely to occur than in the control group. Now, an odds ratio compares that relative odds of an occurrence of something. So an odds ratio really means how many times bigger the odds are of some outcome occurring compared to another value. And it has the same kind of way of thinking about it. If it has an odds ratio of 1, the exposure does not affect the odds of the outcome. If it's greater than 1, it means the odds is greater. If it's less than 1, it means the odds are lower of that event occurring. Both of these also report the 95% confidence interval. And it's in that same concept that we talked about of precision. If you have a tight confidence interval, meaning it's a very small difference between the two numbers, you have a high amount of precision. And that's typically associated with larger sample sizes. Also, if the confidence interval includes 1, either for odds ratios or relative risk ratios, the result will not be statistically significant. And so it is important to understand. All right, so they will calculate, with both of these, they can calculate the 95% confidence interval. And you can see the formula here. You don't need to memorize this, but I just show it to you so that you can be familiar with it, okay? And you can pause the video and look at this a little bit closer. This figure is a nice way for you to remember risk ratios and odds ratios, okay? If either one of them crosses 1, you cannot reject the null hypothesis. If it's less than 1 or greater than 1, if it's in this area over here or in this area over here, then it's significant. But when it crosses that line, it's not significant, okay? And so that is an important concept to remember. All right, here's a couple examples for you. I've made up some data, and so this is, say, a prospective cohort study that's looking at the relationship between whether or not a wet tap occurred and whether or not a patient develops a post-dural puncture headache in 500 women, okay? So you can see here we have yes or no, the event occurred, so this could be our dependent variable. and our independent variable could be whether or not they had a wet tap. Okay, so I put the frequencies of each event occurring in each of the boxes, and I went on this calculator called MedCalc. You can go to that website. You enter in the numbers there into the boxes, and so here's the relative risk using these numbers. What it came up with is that we had a relative risk of 20 with this, with a confidence interval of roughly 10 to 36. And so the way you interpret this is that parturients who experienced a wet tap were 20 times more likely to develop a post-dural puncture headache compared to those who did not experience a wet tap. You can see here I've presented the data, much like this might be an AMA format here, with the significance values. Let's contrast that to when we look at the odds ratio. Now, a relative risk ratio is actually going to give you a much more conservative number in the way it calculates things. Okay, the odds ratio, if we use the exact same numbers in those boxes there, and then let me go back for you. So here's odds ratio. So this might be in a case control study where this is retrospective, where the investigator is looking back in time, has identified women who had a dural puncture, and yes or no, did they have a wet tap, and those who did not have a dural puncture, and yes or no, did they have a wet tap, and did they develop that headache. So you can see here what we came up with when we entered that numbers in. So the way you interpret this is that the odds of developing a post-dural puncture headache were 96 times higher in parturients who experienced a wet tap compared to those who did not. And you can see here, it's a pretty, not very precise, it's a pretty large confidence interval for that estimate.